In this video, we'll be dealing with linear inequalities in one variable. So before we get to how to solve that, we are going to do a recap of the inequality signs. So we see this means less than. So we can see the shape, we can see that it is tinier at this point and open or bigger at this other end. So meaning that whatever thing that is here is less than whatever thing that is here. So it goes with the way the sign is shaped. So this smaller side, meaning that whatever value that is here is actually smaller or less than whatever value that is on this open or bigger side. So once you see this, that means this value is less than this value, right? So same thing with this, we can now see this is greater than. The first value here, since we read from left to right, the first value here is greater than the second value here. Now this is greater than or equal to. So the value here is greater than or equal to the value here. And this is less than or equal to. Same things. Now we are going to see certain uses when we get to solving. And then actually what we are going to be learning is how to solve equations involving linear inequalities in one variable, and we are going to be representing that on a number line. And here we've been asked to solve 3x minus 4 is greater than 8. So what we are going to do is we are going to collect like terms. So we solve this like a very normal equation. So this is a term on its own. Then we send the constant values here. 8 is already here. Then negative 4 is going to cross over the inequality sign to be a plus 4. We have that 3x is greater than 8 plus 4 is 12. Then in a normal equation, what we do at this point is to divide both sides by 3 so as to eliminate 3 from here, that our variable is standing alone. When we divide both sides by 3, we have that x is greater than 12 divided by 3 is 4. So x is actually greater than 4. Then on the number line, once our variable is represented here and the constant value is represented here, it's very easy. What we are going to do is we are going to draw a number line, and then we are going to indicate a 0. 4 is on this side of the number line, right? So we are just going to represent that number. We don't have to fill it up. Then we are going to put what I would call a searchlight. It's not called a searchlight. That's just my own terminology. So I'm going to put a searchlight here. And then wherever this arrow is facing, wherever this sign is facing, that is where it's going to face. Then this is going to be shaded if this was or equal to, greater than or equal to. But since it's just greater than, that means it's not going to be shaded. And what does that mean for us? It means that the values for which this inequality is going to be true are values of x, are for values of x that are actually greater than 4, not including 4. So we have 5, 6, 7, 8, and the rest of them. Now let's get on to the next example. Solve the inequality 6x minus 14 greater than or equal to 13x. We collect like terms, of course. Now I like to collect the unknown variables on this side of the equation, on the left hand side of the equation. 6x, then 13x crosses over to be a negative 13x. We have our sign greater than or equal to. Then negative 14 crosses over the inequality sign to be a positive 14. 6x minus 13x is 7x, negative 7x. And then we have that it is greater than or equal to 14. Now we are going to divide both sides by negative 7 so as to eliminate this from here, that our variable stands alone. Okay, now when solving inequality, if you're going to multiply both sides or divide both sides by a negative number, the sign has to be reversed. So let's see what that means. We are dividing both sides by negative 7. So the minuses cancel out, the 7s cancel out, we have that x. Now this sign is going to be reversed. Instead of being greater than, it's going to now be less than or equal to. 14 divided by negative 7 is negative 2. So we have it that it's now equal to x is less than or equal to negative 2. And on our number line, very easy to write. We have to indicate our 0. And then negative 2 is on this side of the number line. So on this side of the number line, we have negative 2 represented. Then we are going to put our searchlight here. And the arrow is going to be facing this way that the inequality sign is facing. And then we shade our searchlights. That's my terminology. Remember, that's not its name. So we shade it. Why? Because it says less than or equal to. So meaning that this value, that is what or equal to means. Whenever it's greater than or less than or equal to. What it means is that that value is also part of the answers. That is part of the values for which the inequality is true. So if you're asked for what values is this inequality true, it includes negative 2. And then every other number that is less than, that is on this side of the number line. So we have negative 3, negative 4, and up to negative infinity are also true for this inequality. So we see the need for or the use of the number line, right? Now for the rest of the video, we're going to be doing perfect practice, which makes for perfection. For what range of values of x is x plus 3 less than or equal to 4x? Okay, our usual way, we have x, then we collect like terms, right? So 4x is going to come here to be negative x less than or equal to, then the plus 3 crosses over to be a negative 3. We have x minus 4 is minus 3x. Then we have, now we are to divide both sides by this negative 3 so that x can stand alone. Okay, so we already know the rules. Once we divide or multiply both sides of an inequality by a negative value, the sign has to be reversed. So this becomes greater than or equal to 1. Negative 3 over negative 3 is 1. So on the number line, we have it as this. So this is 0, 1 is on this side, 1 is on this side. So this is for the x-axis, right? So we put our searchlight on 1, and it's going to be shaded. Why? Because this is or equal to, and then it's going to be facing this side just like the inequality sign is facing. So for what values? For what range of values? So it's from 1 and above. 1, 2, 3, and the rest of them. Okay, so we solve this. We have x plus 9 greater than 5x minus 7. We collect like terms. We have x here. 5x crosses over to be a negative 5x. We have the greater than sign. We have negative 7 already on this side. Plus 9 is going to cross over to be a negative 9. X minus 5x is negative 4x greater than negative 7 minus negative, that is minus 9. So it's going to be, the value is going to be negative, but we have to add the values, right? So we have, that is 16, negative 16. We divide both sides by minus 4. Now we are practicing these negative divisions so that it registers in our memory that whenever we divide both sides by a negative value, the sign has to be reversed. So x is equals is now less than negative 4. So on the number line, we are also practicing this. So negative 4 is on this side of the number line, right? We put our searchlight on that. It's not going to be shaded because this is not or equal to. And then it's going to go the direction of this sign. So this is it. So the values are negative 4, negative 5, and the rest of them. Okay, now let's deal with this that has a bracket. X minus 1. So we open up the bracket, we have 2x minus 6 less than 3x minus 3. We collect like terms, right? We have 2x minus 3x less than negative 3 is already here. Then this negative 6 crosses over to be a plus 6. 2x minus 3x is minus 1x, or just minus x. We have negative 3 plus 6, that is positive 3. We divide both sides by negative 1. So we have, they cancel out, we have that x, the sign has to reverse because we divided by this, we have greater than negative 3. And on the number line, well, that line wasn't it. So on the number line, we have 0, negative 3 is on this side. We put our searchlight here, right? It's not going to be shaded because of this, and it's going to focus on this side. So the values are -2, -1, 0, 1, 2, 3, and the rest of them.